Hello, my name is Steph, and today we'll be learning Yellow Cipher. Yellow Cipher is part of the Rainbow Cipher family, and it's one of the more easier ones, although it is still a bit hard.
This is the story of
All available experts, please report to room A9.
Alright, I'm too lazy to just write down edgework, so let's just hop right into this. Actually, before I relook at the manual, let's just write down everything we see. So, that's the manual, that's this one. So, on our first screen, we have the encrypted word, and on this screens with numbers, you just want to concatenate them all into one number, except for this part right here. You want to keep that as its own thing. This will be our keyword, and this will be our key number for the Hill Cipher. Anyways, we don't need to look at this until we disarm it. So, first thing we do is we take our keyword, and we want to put a bunch of X's beneath it. Now we want to put numbers underneath them in alphabetical order. So since C is the first one, is first alphabetically, so we put one under this. E is the next one, so we put a 2 under this. And then we keep going until we go to 8. E, F, G, H, I, J, K, L, M, N, O, P. 6, 7, 8. Then we want to copy this keyword,
clear. All personnel, please return to your stations.
This thing on manual, this key, and put it underneath this. Now we take our number from before, and for each number we want to copy down the more symbols in the column that they're given in. So for example, our first thing is a 1, so we look into our key message, we find the column with a 1, and we record the symbols beneath it. So in this case, since 1 is a C, and C's column is dash dot, our message is dash dot so far. We do this for each one. For 6, we have dot dot. For 8, we have break dot. For 2, we have dot dash. For 5, we have break dash. For an 8, we have break dot. 1 gives us dot dash. 7 twice will give us dot break dot break. Yep. 2 will give us dot dash, and 7 again will give us dot break. This should give you a word, and it's the same keyword I got the other day. So this spells out butler. This is B-U-T-L-E-R. If you do not get a valid word, you did it wrong. Most likely, you just forgot how the alphabet works. So next thing we do is we write out the entire alphabet. D, E, F, G, H, I, J, K. J, K, L, M, N, P, Q, R, S, T, U, V, W, Z. And we take, if I remember this correctly, we take the word butler, and we remove all instances of that in the alphabet. So B-U-T-L-E and an R. Now then, if number of batteries is odd, place the alphabet at the end of the keyword. So let's just take a look at the bottom real quick. 1, 2, 3, 4. It is not. Okay. So since it's an even amount, we place the alphabet at the beginning of the keyword, meaning that butler goes back here. Now we copy and paste this entire thing underneath the alphabet. So what we do is we grab our encrypted word from the top of the screen. This thing up here, and we copy down the three-digit code for that letter. So for B, it's 313. For G, it's 122. For P, it's 221. For Z, it's 312. For a U, it's 321. For an I, it's 131. Then, we make it into 3 rows, each of them containing 6 numbers. Now we go down the columns and record the letter for that column. So for 323, we go to the first row, which is a 3, the second row, which is a 2, and the third one, which is a 3. This will become an L. 122, so 1, 2, and 2. That becomes a G. 3, 1, and 1. That becomes a Y. 1, 3, and 1. That becomes an I. 2, 1, 3. That becomes an O. 2, 2, and 1. That becomes a P. So this is where most of the time this is what will take most of the time, the Hill cipher. So, okay, so these are our letters, A, B, C, and D. So, let's copy down this equation right here. % means modulo, just FYI. So we want to make this equation true, and we have to find out what n is. So let's see. We take it's going to be, we take 1 times 23, which is just 23, since that is our value A times D. We're going to subtract the product of B and C, so 2 times 14, which is 28. That will give us -5. -5 modulo 26 should be 21. Yep, because 5 plus 26 equals 21. So, that's a 21, so that's out the way. So, n is always going to be a whole number. So, we want to know we want to make this equation true. 26 equals 1. So, what you have to do is you have to get all your multiples of the current number, so for this case 21, 42, 63, 84, etc, etc. And you want to modulo that by 26. That multiple in the sequence is going to be n. So I'm going to just get all multiples of 21. Okay, I'll just put this in the next page. 42 mod 26. That gives us 16. Okay. Yeah, this should be enough. Okay. Our next one is 63. 63 mod 26. That does not give us 1. 84 mod 26, that gives us 6, so that doesn't count. 105 mod 26 equals 26. So 105 divided by 21 will give us 5. So n equals 5. Now, what do we do with that? Let's get rid of that. We arrange our numbers in the way that this is given. So we have 23, negative b, so negative 2, negative c, which is negative 14, and 1. Okay, then we multiply each one of these numbers by n, and then modulo by 26. So, just gonna do some math here. Multiply that by 5. Yep. Subtract 26. So our result will be the number top in the respective position. 5 times negative 2 is negative 10. Mod 26 will be 16. Negative 14. Well, 14 times 5. Negative 70. Negative 70. Mod 26 will give us 8. And then 1 times 5 is just 5. Then we take our alphabetical position of each word, and so we take the alphabetical position of each word, which in this case, which is 12, 7, 25, 9, 15, and 16, and we split them up into pairs. For each pair, we want to multiply the top number by the top left number in the Hill cipher. So 12 times 11 is 132, and we want to add the product of the bottom number and top right. So 7 times 16, that's a big number probably. 7 times 16, 112. Now we get the sum of this and modulo that by 26. Alright. Which should give us 10. And the 10th letter of the alphabet is Juliet. Now, we take the top number and multiply by the bottom left number. So 12 times 8 is 96, I believe. Let me just double check. Yep, okay. And 7 times 5 is 35. So again, we take the sum and we modulo that by 26, and that'll give us 1. Now, we grab the letters for, we get rid of these letters, we don't need them anymore, and we move on to our next pair, so 25 and 9. 25 times 11 should be 275, and 9 times 16 is 144. So, we take the sum, which is 419, modulo 26, and we get 3. So, it's a C. 25 times 8, that is 200. And 9 times 5 is 45. So 245. Excuse me. Mod 26 gives us an 11, which is a kilo. Then we take our final pair, which is 15 and 16. 15, so 165. Again, 15 times top left, and then 16 times top right. I should know the square of those. I believe it's... whatever. 16 times 16, that's 256. Should have known that. Again, we grab the sum. We take the sum modulo 26. That gives us an E. Alright, now we do it to the bottom. 15 times 8, that is 90. And we take 16 times 5, which I believe should be 80. Yeah, it should be 80. And that'll give us 170, if you can do basic math. So 170 mod 26 will give us 14. 14 being... I don't know. Jacking? No, that's not a word. Oops, technical difficulties. 2 times 8. Yep, okay, I knew I can't math. 15 times 8 is 120. So 120 plus 80 is 200. 200 mod 26 is 18. Jacker. So yeah, and actually just to confirm, 16 times 5, this is why you don't do mental math. 80, okay, yeah. So, after we got our final word of Jacker, that is our solution word, so we entered Jacker into this. J-A-K.
This was exactly right now. The thing.
And that is a yellow cipher. Let's just do one more for good measure.
All available experts, please report to room A9.
Let me delete all my notes real quick. Okay. Again, let's just let's just write down what we need to know. So we have the key, well, not the keyword, the encrypted word. We concatenate this into one number, 63. Alright. And we also concatenate the top number, so 827388. This is going to be a pain. Inventor 14, 19, 1, and 10. Alright. So, let's just get off this page. I'll keep it. Why not? Again, we take inventor, place all the X's beneath it, and put numbers based on the alphabetical position. A, B, C, D, E, 1, H, I, J, K, L. I forgot what I do in terms of ties. Okay, if there was a tie, you place them in ascending order. So since there's two N's, I put the 3 here and the 4 here. Then, we continue on as usual. So, 5, 6, 7, and 8. Again, we take the key from before, copy and paste it. Four, okay, and we take this. Okay, so, well, we should put it beneath it. 4, which is this column, is going to be dash dash.
Please return to your
7
stations.
is going to be dash break. 1 is going to be dash dot. 2 is going to be dot dot. 5 is going to be break dot. 2 is going to be dot dot. 6 is going to be break dash. 3 is going to be dot dash. 8 is going to be dot break. 2 is going to be dot dot. 7 is going to be dash break. 3 is going to be dot dash. 8 is going to be dot break. And 8 is going to be dot break. So, again, we convert this, so it's O, B, S, C, obscure. Okay. Obscure, and again, we type out the entire alphabet. G, H, I, J, K, L, M, P, Q, R, S, T, U, V, W, X, and we remove all of the duplicate letters. So, O, B, S, C, U, R, and E. Now we need to know if the amount of batteries we have is even or odd. 1, it's odd. So, if it's odd, then we want to put the alphabet at the end of the keyword. So, basically the alphabet just goes at the end. And again, we copy and paste this key. We take our word from our encrypted word, and we convert that into 3 rows of 6. So R down this row is 1, 2, 3. L is going to be 2, 3, 1. Okay, new row. E is going to be 1, 3, 1. O is going to be 1, 1, 1. B is going to be 1, 1, 2. And S is going to be 1, 1, 3. Okay, 1, 1, 1 is an O. 2, 3, 1 is an L. 3, 1, 2 is going to be a Q. 2, 1, 1 is an F. 3, 1, 1 is a P. And 1, 1, 3 is an S. Alright, now that we have that, we have the hill cipher again. So, A, B, C, D. Okay, and I just copied this equation down so I don't forget how to do it. Let's see, so 14 times 10 is 140 minus 19. That should give us 121. Okay, 121 mod 26 is 17. Okay, now we look up the multiples of 17. This should be enough. I'll just say this. It can, because n is stupid, it can go up to the 25th multiple of your number. So, that's pretty fun. Alright, so our number is 391. 391 divided by 17 is going to be 23. Wow, we were unlucky. So n equals 23. Alright. Again, rearrange the numbers like so. So it's going to be 10. Negative b, so negative 19. And 14. Alright, and we multiply each of these by 23, and modulo them by 26. So 230 mod 26, that becomes 22. Negative 19 times 23. That's negative 437. If you were to do this by hand, you would easily increase the time you take to do this by about 12 years. Negative 23 times negative, no, 23 times negative 1 will give us negative 23, meaning this is just 0, not 0, 3. No, 14 times 23, 332, gives us 10, right? And we grab this, and again we split these up into pairs, so 15 and 12, 17 and 6, 16, and 19. Let's see. 15 times 22 gives us 330 plus 60, since 12 times 5 is 60, so 390. 390 mod 26, that would give us 0. I was hoping this would come up. If you ever get 0, 0 is Z, or Zulu. 15 times 3 is 45, and that 12 times 10 is 120, so 165 mod 26. Yeah, that's an I. Again, we get rid of this, and replace our next number here. 17 times 06. Okay, so 17 times 22 is that number, and 6 times 5 is 30, so that will give us 404. 374 plus 30, oh yeah, it's 404, mod 26. 14th letter is in November, alright. 17 times 3 is 51, and we're gonna add 60, so 121 mod 26 is 17. 17th letter is a Quebec. Did I do math right? I don't think I did. Alright, well, that's a Q. All the ciphers have like some obscure words that no one has ever heard of, so that's a great thing to keep in mind. Alright, 16 times 22 gives us this number. We gotta add 19 times 5. 19 times 5 plus 9. 447. And 426 is 5. Alright, I made a mistake. Let me just double check where I went wrong. Alright, well, I just did math wrong, so this E is correct, so I'll just put this off here. But let's go back to our 17 and 6. Since it's the 4th letter, we want to multiply 17 by 3. I probably inputted the number wrong, so we have 51. 6 times 10 is 60. 60. Yep, it's 111. 111 mod 26 will give us a 7, and the 7th letter is a G. The Z was correct, so we'll just move on. This becomes a 6, and this becomes a 19. 16 times 3 is 48, plus 190, since 19 times 10 is 190. We add these together, should be 238. Yep. Alright, and then we modulo this by 26. Oops. Mod 26. Gives us a 4. Bing bazinga. So, we enter in zinged. Bazinga.
Right now, the things were meant.
That's all I have to cover for Yellow Cipher, and no, just watch my other tutorials and get a job.